Hello everyone, in this video I'll be explaining you the problem plus 1. So you are given a large integer represented as an integer array digits where digit of I is the ith digit of the integer. The digits are ordered from most significant to least significant in the left to right order. Okay, the large integer does not contain any leading zeros. Okay, got it. So increment the large integer by 1 and return the resulting array of digits. Okay, so we have given 1 2 3. Let's try to understand this problem statement and let's go to the board. So what they have given is we have digits as array where we have 1 2 3. So in the question what they have asked is this digits is an array which which represents some number. Okay, and they have said this is large, and whatever number they have represented, so if you want to represent, let's say, number 1 5 4 3 2 1, something like that. So it's this is the most significant bit, right? And this is second most, this is third most, and this is least significant bit. So they have said most significant to least significant is from left to right. Left to right in the array. So which means if you see in this array, this is most significant bit, and this is second most, and this is least significant, and it's like the number 1 2 3 123. It's like this is the number. So now what they've asked is we have to make sure we have to make this large as large is a number large plus 1. So whatever number you're getting, like if you add plus 1 to this, you're getting 1 2 4. So now you'll have to return in the array 1 2 4. Okay, so this is the question asked. Now if you see the constants, so digits can be 10 power 10 power 2, yeah, like it's 100. So the digits array length is 100. Okay, so how can we solve this? Now as I said, like this is 123, if you're adding 1, so you'll be getting 124 and this is the array that you need to return. Okay, so let's understand this, how to solve. So what I'll do is I'll try to reverse this. Okay, if you reverse this, we have 3 2 1. Okay, now even if you don't reverse, what will happen is somehow you'll have to iterate in the array from the back end. Okay, like from the this side, from right to left to traverse, and then we'll have to add 1 here. When you're adding 1 here, so it is going to be 4. That is true. So it is 4, it does not have any carry, so that's why the carry is not added to this. This number remains as it is. Okay, so this is the value that will be array will be returning. So you can do from right to left, but also you can but I'll not prefer this. I'll tell you why. Let me take one more example. We have digits as 4 3 2 1, and it's like number 4321. When you add plus 1 to it, it is 4322. Yeah, 4322. Okay, so again what we'll do is we'll move from back, we'll add 1 to it, so it is 2, it is not have any carry, so all this number will not change. So this is the array that will be returning. Okay, now the thing is, if I consider digits, the one more case wherein we have 9, and you have 9, when you add plus 1 to it, it is going to be 10, right? So when you are adding 1 to it, from the backside what I'll be adding, so 1 you are adding, so it is 10. You have 0 here, right? and then 1 you need to add it. So when you are adding 1, now it's like it is array, right? So you'll have to add to the front of the array. So that's the reason uh, of okay. For now, let us think we are adding in the front of the array. So this is the digit that digits array that will be returning. But how do you insert this, right? We can insert at the back. It's like whatever number you have, you can insert at the back. Later you can put this element to the front of the array. So it is going to be this thing, like we need to swap. Okay, so this is also one of the solution, but what I'll try to do is I'll try to reverse the array. Like let's say whatever number you have, let me take 4 3 2 9, or here also I'll take 9, here also I'll take 9, and then here also I'll take 9. Okay, so what I'll try to do is I will reverse this array basically. When you it's like when you have 4 3 2 1 as the digits, so when you reverse it you'll have 1 2 3 4. Now I'll go from front of the queue, front of the vector, I'll add 1 to it, right? When you add 1 to it, it is like 2, then carry is not there, so this remains as it is. Now again you reverse it, this is the vector that you need to return. So similarly what I'll try to do is I'll try to reverse this. When you reverse this, now 9999 remains same only. Okay, now you need to add 1 to it. When you add 1 to it, it is 10, so 0 will go here, 1 is carry forwarded. Again 1 plus 9 is 10. Okay, so 1 is carry forwarded. Again 1 plus 9 is 10, so 0 1 is carry. Again we have 10, so 0 1 is remaining. So what now you need to do is you need to push back 1 at the end of the array. So this is the number that we got. If you reverse it, you will get the original number. Okay, so yeah, in this way we will be solving problem. So basically only first time we'll have to add 1, and remaining time we need to take the carry. If you have any carry, we need to take it. Let's try to code it up. So first thing first, what we'll do is we will reverse this digits. Once we have reversed it, now we'll have to add 1. Let's see the digits array length, it is 1. Okay, so I'll name a variable add, which is equals to 1. Now I will add at the first I'll take one value which is going to be digits, sorry, it is the digits of 0, whatever digit is digit is present as 0th index, because it is reversed, so it is least significant, plus add you will be doing. Okay, so you have added. Now your digits digits of 0 will contain now value modulo 10. Why value modulo 10? Because when you're adding something, so it's like you have 9 here and you're adding 1. Okay, it is like 10, value is 10. So in the digits place you need to have 0, right? And then carry is 1. So if you do 10 modulo 10, it is 0, and your carry is going to be value divided by 10. So it's like 10 by 10 is 1, so your carry is 1 and here it is 0. So that's the reason, right? Now I'll move into the loop, and from one index I'll take, and what is n? N is basically the size of digits. And why I'm taking a loop from 1? Because for the 0th least significant position or 0th position I've already dealt here. Now if we have any carry, then we'll have to do certain things. Before that, we need to check if carry is equal to 0. It implies we don't have any carry. So if there is no carry, so the all other digits remain same only, right? So we'll have to break it out. Okay, else this value again is going to be digits of I plus carry. Okay, and then your digits of I will hold value modulo 10 and your carry will hold value by 10. Okay, now this case if you consider 9, okay, so 9 if you consider, it's like the previous size is 1, right? Digits array length is 1, but in the array it is 2. It is because this is the most greater number, because at any significant bit the number will be from 0 to 9. So it is the most, when carry is added, when we have added 1, so it is going to be 10. So it's like 10 is represented as 1 0. So in that case it's like 1 carry we have, right? So if at all we have carry after this for loop, which means one extra digit we are getting in the number. So we'll have to check if carry equals to 1. So in that case your digits dot pushback is going to hold this carry. Okay, and now the number is in reverse order. Again you have to reverse the array. At the end you will have to return this digits array. So what I'm right now, what I'm doing is I'm just currently changing in this digits array only. Okay, and if at all you want to remain you don't want to touch this digits value, so you can take one extra vector and then you can do it. Let's try to submit it. Here it got accepted and beats 100% of the user. So if you try to analyze the time complexity, so reversing will take n by 2. Okay, and this is going to take O of n. So and this is also n by 2. So it's like O of 2n. So it's like linear, and space if you see we are not using any extra space to solve the problem. So it's constant. So yeah, in this way you got to easily solve the problem. So thank you guys for watching the video.